This is a quick walkthrough on how to set up ContextCaddy. ContextCaddy is a Chrome extension that provides a high-level UI to interact with MCP cabinets API. MCP cabinets allows for the categorical indexing of context to then later be delivered through the Model Context Protocol to your respective tools or agents or systems. First thing you're going to want to do is clone the backend code where you can navigate to the API service and then run UV-sync to initialize the environment, all inclusive within the virtual environment. It installs Python and handles everything within. It's nice about UV. And then we can activate the virtual environment and start up the server. This is fast API with Llama index under the hood. It just provides a clean interface to create categorical indexes. And we can add a wrapper. So what we do is add a wrapper for our MCP server. Anyway, next you're going to want to navigate to the MCP service where you can run UV-sync once more, completely disconnected module with its own dependency and environment. Now since that's set up, it can be activated for our tool which utilizes our MCP server if we choose to do so. I'll be showing an example with Cherry Studio of how to set that up. I know it works with Cloud Desktop or any application tool which implements the Model Context Protocol. And it's really easy plug and play. Now we can go ahead and open a new terminal and clone the Chrome extension code. I'll add these all to the description and these links to the description in the order I state them. So once you download or clone that, you can navigate to the root. And actually this has zero dependency, but I'll go ahead and show the code. It's pretty simple, all top level. A lot of the effort went into the back end, has been a theme. So since the server is all started up, we can go ahead and navigate to our browser, check out our local server port 8000 by default. You see the Swagger docs here show that everything is looking good. This is our simple set to interact with our indexing capabilities. The Chrome extension will utilize this API to create RESTfully or otherwise RESTfully interact with our data indexes, and then what we can do is go to this URL, which I'll add as well. Make sure developer mode is on. Go to load unpacked, and then you're going to want to select the ContextCaddy folder, just the root. And now we can go ahead and use this in developer mode. I'll show you. You want to pin this here for easy access. So now go ahead and open up the side panel, and it will stay whichever, it'll persist across tabs, which is nice for navigating different tabs, trying to collect chunks of context for categorical indexing by your model. Let's go ahead and go to perplexity just to show an example. Green means the connection is secure. It's using the health endpoint, which is part of the Model Context Protocol, so that it can validate existence and health of the server. So now we can go ahead and say we created an animals cabinet, right? So now this will persist. It's stored in my directory structure, and I can set up otherwise using Llama index and certain configuration in the configuration file for API, which handles storage. I can go ahead and drag and drop. Say I give me a quoted fact about it knows. So now one way I could do it is left click, add to context cabinet. There we go, I added my chunk. Something unique about this is that traditionally chunking occurs algorithmically or otherwise under a layer of abstraction. This gives, and that means it requires some overlap often. When we pass that capability to the human expert, they can create the chunks themselves, and thus overlap is not needed, and we can hit a higher accuracy, especially for niche expertise and that which is outside the realm of the training data set. I can go ahead and say find a quote about eagles. There we go. Just some random quote. Another way I can do this is just drag it like that. Boom. 2 chunks. Human facilitated chunking. If I wanted, I could make a favorite, or let's just call it foods. You can call it whatever you want. Foods. Now I can go ahead and say describe a McDonald's Big Mac. Alright, let's go ahead and take a bigger chunk. We have the capability to add an upper and lower bound for our chunking. That way, if we're in flow state, we can kind of just make sure to exclude mouse slips and otherwise lapses in judgment for context that could not possibly be robust. Next thing you want to do is probably add one more food item just for to be thorough. Find a description of apples. Sure, apples and Big Macs. So here's a little description of apples. So say I know exactly where to end it because I'm the expert. So rather than have some algorithm handle it chunking, I'm going to chunk it myself. And I can go ahead and drag this in here. So now we have that as well. And I can go down, something cool here is I can go down here and test it. So I can say, I can kind of imagine that I am the large language model. I am the tool. And I have seen that there is a food cabinet. Now I'm passing off whatever context or prompt to the other tool function, which allows me to retrieve the relevant, semantically relevant chunk. So I'm going to go ahead and say round, red, and delicious. See if that works. I mean, it's super simple Facebook legacy indexing. It's not advanced. They have some pretty good, you can see that, and I convert the relevancy to a percentage for better conceptualization. And you can see that it scores the apple slightly higher. And it's not just purely regex matching, but I do have that for visual aesthetic, a diff type pattern or visual. So that's how you can kind of test it out, get a feel for how prompts are being processed by your choice for Llama Index, your indexing service. And all that's very configurable with Llama Index. And it also lets you understand it lets you see what, like imagine you're the model. So anyway, those are the examples I've loaded, and now I'm going to show the MCP. So when you're done loading the context, you can imagine that you could load a massive amount of context into a large number of categories, potentially, or cabinets. And then you would go ahead and make sure that you have you're going to want to navigate to the MCP service so that you can extract the configuration JSON. Where is that? mcp.config.json, and pipe that or actually I don't even need to. So now copy and paste that, and that's the plug and play aspect where it's gonna start up this server and allow the model to interact when activated. So here's Cherry Studio. If you're using Cherry Studio, you can go down to the MCP settings, add a server. Go ahead, just copy and paste, very easy. Make sure the path lines up though. And I'm gonna keep it absolute just to make sure this works. I don't want to start over. All right, there we go. Okay. All right, let's see. We're all set. It's all connected. So now I'll go ahead and show an example. So just an example of how another cool thing about this is that it kind of subjugates the routing of, I can in real time just route it to a certain cabinet, or it can list the cabinets and decide on its own which is relevant. Either or. It's a very flexible approach, I think. Oh wait, I forgot to select it. So you got to select the MCP server to grant it access. So now it's going ahead and using those tool capabilities. It listed the cabinets. It sees that there is a foods cabinet. So I found, and now it indexes that cabinet by passing my prompt. And you can imagine the higher complexity. This is a very simple example, but it's able to interact with these tool functions. You can see them through the UI here. If I go to, here we go. So retrieve from cabinet, list cabinets. So these are functions that the model can call in a facilitated, managed way. And that's pretty much it. Thank you for watching.